With this video we want to educate our whatchers about the main components of solar PV system. Main solar system parts. Solar panels. Panels mounting structures. Solar MPPT charge controller. Solar inverter. Switchboard. Electrical and safety equipment. Wires for solar panels DC and AC high voltage output. The meter and electricity grid. Let's see how it looks and works. Solar panels. Solar panels or solar modules are installed together in what is known as a solar array. Modern solar panels are made up of many solar cells or photovoltaic, PV, cells which generate direct current, DC, electricity from sunlight or energy from the sun. Note, it is light energy or irradiance, not heat, which produces electricity in photovoltaic cells. Panels mounting structures. These are fixtures that hold the solar panel in place. Their appropriate design is essential to make sure the panels get maximum sunlight. The mounting structures are usually made of galvanized iron or aluminium. They have to design for wind loads applicable in the region. There are two types of mounting structures. The mounting structures are long-lasting and require no maintenance. Solar MPPT charge controller. An MPPT, or maximum power point tracker, is an electronic DC to DC converter that optimizes the match between the solar array, PV panels, and the battery bank or utility grid. To put it simply, they convert a higher voltage DC output from solar panels, and a few wind generators, down to the lower voltage needed to charge batteries. Maximum power point tracking is electronic tracking, usually digital. The charge controller looks at the output of the panels and compares it to the battery voltage. It then figures out what is the best power that the panel can put out to charge the battery. It takes this and converts it to best voltage to get maximum amps into the battery. Remember, it is amps into the battery that counts. Most modern MPPTs are around 93 to 97% efficient in the conversion. You typically get a 20 to 45% power gain in winter and 10 to 15% in summer. Actual gain can vary widely depending weather, temperature, battery state of charge, and other factors. Solar inverter. Solar panels generate DC electricity which needs to be converted to alternating current, AC, electricity for use in our homes and businesses. This is the role of the solar inverter. In a string inverter system, solar panels are linked together in series and the DC electricity is brought to a single inverter which converts the DC to AC. In a microinverter system, each panel, or every two panels, has its own microinverter attached to the backside of the panel. The panel still produces DC, but is converted to AC on the roof, and is fed straight to the electrical switchboard. Switchboard. AC electricity is sent to the switchboard where it is directed to the various circuits and appliances in your house that are using electricity at the time. Any excess electricity is sent to either a battery storage system if you have an off-grid or hybrid system, or to the electricity grid if you have an on-grid system. Electrical and safety equipment. The different parts of PV system are connected by cables on DC and AC side. It is also important to install safety equipment since PV systems are designed for long life use. Electrical surges or short circuit can damage the equipment. Proper earthing and equipments like RCBB, surge protectors, lightning arresters, etc. are required. RCBB, residual current circuit breaker, will protect the system against current leaks, which may lead to shock or fire. An SPD, surge protection device, protects the equipment from surge voltages created during lightning and grid fluctuations. These components are same anywhere in the world. However, based on the region of your residence, the type of these components used may vary. Solar power systems have a long life. Therefore, it is important to emphasize on quality and safety for durable performance. The battery bank. In hybrid system, once solar power is used by the appliances in your property, any excess power will be sent to your battery bank. Once the battery bank is full, it will stop receiving power from the solar system. Wires for solar panels DC and AC high voltage output. Choosing the right wire for your solar energy system is critical to its functioning properly and remaining undamaged. If you get this wrong and choose a PV wire too small for your PV system, your battery bank may not charge fully, and as a result your appliances might not work as well or at full power. Thicker PV wire costs more than thinner PV wire because it can handle more amps. When choosing the thickness of your wire, you can go one of two ways. A little thicker for safety, or just thick enough but vulnerable to sudden power surge. A great way to go about choosing the wire thickness for your solar system is to buy solar panel wire big enough to cope with the biggest current, amp, drawing appliance you have, and using that wire for all the other runs to the AC breaker panel. Use a wire sizing calculator for solar arrays that will figure out the size of wire you need. The insulation covering wire can protect the cable from heat, moisture, ultraviolet light, or chemicals. The meter and electricity grid. Depending on how your hybrid system is set up and whether your utility allows it, once your batteries are fully charged, excess solar power not required by your appliances can be exported to the grid via your meter. When your solar system is not in use, and if you have drained the usable power in your batteries, your appliances will then start drawing power from the grid. Conclusion. Gaining the knowledge needed to design and install a safe, efficient system not only ensures that your system will meet your needs effectively but also keeps you and your home safe and helps to promote the acceptance of renewable energy as a mainstream energy source. We are thrilled that you are pursuing a PV system. Whether you choose to install the system on your own or whether you hire a professional installer, please contact the PWM company for solar systems components or for installation. Thank you for watching.